Math students, welcome to our review on factoring. If you are currently taking pre-calculus or honors pre-calculus, factoring is going to be a vital skill that you're going to need and that you're going to use a lot in the coming year. So if you need a quick review on some of the factoring strategies and patterns, here we go. Let's get started. So first step of factoring, it's usually an easy one, but it is one that sometimes people overlook. As we get into all these other strategies and patterns, sometimes students forget this very first one. And your very first step in factoring is to see if there's a common monomial that will divide out of every term. So basically, as we look at all those terms, is there something that we can divide or factor out of every one? So hopefully you're looking at that and you're saying we can factor a 3 out of every term. And so when we do that, we factor out the 3, then what is left in each term as we factor or divide the 3 out of there? Our first term, we would just have an x cubed. The second one would be a 4x squared. 9 divided by 3 would be 3. And then 15 divided by 3, or negative 15 divided by 3, would be negative 5. And so there's always our first step. Sometimes if you have a very complicated looking polynomial that needs to be factored, a lot of times just remembering this first step will make it a lot easier after that. Moving on. When we are dealing with binomials or polynomials that have 2 terms, there are very distinct patterns that you should know and have memorized. We have the difference of 2 squares and then the difference in the sum of cubes. These are very defined patterns that you'll want to know so that the moment you see one of these binomials, you'll know how to factor it very quickly. Feel free to pause the video right now and write these down if you need to. When you're ready, hit play, and then we'll resume and we'll show you some examples. All right, so let's use those patterns on the previous slide to factor these binomials. All right, in the first one, again, don't forget our previous strategy. Is there something we can factor out of both terms? Hopefully you recognize that we can factor a 2 out of both of those terms. So after we factor the 2, we are left with x squared minus 16. Now from here, you should hopefully recognize that those are both perfect squares. X squared and 16 are perfect squares. So really what we do is we take the square root of each one of those. So that would be x and 4, and we just make it x minus 4, x plus 4. So that is our pattern for the difference of 2 squares. Looking at example number 2, now we have the difference of 2 cubes. So usually it might be helpful before you start to use that pattern on the previous slide is to determine what a and b are. So a and b are just the cube roots of each of these terms. So in this case, the cube root of x cubed would be x. And here, the cube root of 27 is 3. Don't worry about the positive or negative. We're going to take that into account shortly. So now that we've determined what a and b are in that pattern, a and b are just simply the cube roots of each term. Now we can use that pattern on the previous slide to factor it. So now when we factor this, again, the first parenthesis will have a minus b. And then the second parenthesis will have a squared. Now, if we have a minus in the first parenthesis, we're going to have a plus in the second. Then we multiply a and b together. And then we take the square root of b, which in this case would be 9. And there is the factorization of the difference of those 2 cubes. If you're not sure that that works, if you go ahead and multiply those 2 factors back together, you will in fact get x cubed minus 27. Three terms. This is the one that usually tends to be the most challenging because it doesn't have a very distinct pattern. And so because it doesn't have a distinct pattern like the binomials, a lot of times it can give people trouble. And as a result, there have been a lot of different types of strategies to help people make sense of this, okay? When I was much younger, I was just taught to do trial and error. You looked at the first and last terms. What did they have to be and which combination worked to combine to give you the middle term? So that was the way I was taught. Here are some other common strategies that you might be familiar with. The box method or the cross method. And so if you have done either of those before and you're comfortable with those, you may continue to use those. As I said, I was taught just trial and error. So at this point, I can usually look at a trinomial and know very quickly how to do it or do some quick trial and error to make sure it works. So we have this example down at the bottom. So if I were doing this one, I would look at it and I know it's always going to be 2 parentheses. And then I know that my first terms would be x's. I know my last terms have to multiply together to be positive 35, but add together to be negative 12. So that would be negative 5 and negative 7. Now, if you just want to try one of these other methods, so let's look at the cross method, for example. How would we do that here? So on the cross method, we look at the last term, okay? Or actually we multiply the first and last term. Now in this case, our first coefficient is 1. So 1 times 35 would be 35. And then we need them to add or combine. We need our b term to be negative 12. And so now we would look at that and do which combination of numbers would we need that multiply together to be 35 and add to negative 12. And then hopefully we come up with negative 5 and negative 7. And then that's how we would put together the factors there. Okay, so feel free to experiment with different strategies. When it comes to 3 terms, like I said, there's no one distinct way of doing them. And because of that, that can create some frustration. But if you find a method that works for you, then you want to stick to it. 4-term polynomials. Again, we will be dealing with these if you're taking honors pre-calculus and regular pre-calculus. And so again, whenever you are dealing with a 4-term polynomial, usually in a majority of the cases, grouping will be our go-to strategy. So the way grouping works is just like it sounds. We're going to group the first 2 terms together, and then we're going to group the last 2 terms together. Now, one warning here, whenever you group the last 2 terms together, if there is a subtraction sign in front of it, after you put those parentheses in, you do have to change the sign inside the parenthesis. If we were to distribute that subtraction sign to remove the parentheses, we need to be able to get the original polynomial back. So anytime you group terms and there is a subtraction in front of the parentheses, you have to change the sign on the inside of the parentheses. All right, from here, now we just simply factor each group or each parenthesis. So in the first parenthesis, I can factor out an x cubed or an x squared. I am going to be left with an x plus 3. In the second group, I can factor out a 4. And when I do that, I'm going to be left with x plus 3. This is how you can tell that you're on the right track with your grouping. After you factor each group, you should have the same factor in both terms. So notice now that we have an x plus 3 in both terms. So kind of like our first step, when we factor out a common monomial, we're going to factor out the x plus 3 because it's in both terms. Now, after we do that, what are we left with? We have the x squared from the first group, and we have a minus 4 from the second group. Hopefully that pattern looks very familiar to you. We're not done yet because now in that second parenthesis, we have our difference of squares again, a pattern that we should be able to recognize and factor very quickly. So continue on, take our difference of squares, and we'll change it to x minus 2 and x plus 2. And now we have successfully factored that four-term polynomial. All right, so hopefully you found our review of factoring very helpful. There should be some opportunities for you to practice and have a very successful year in pre-calc or honors pre-calc. Good luck.